Hello! Today we're going to do chapter 6.7, which is using the fundamental theorem of algebra. So what is the fundamental theorem of algebra? It says that if you have a polynomial of degree n, where n is greater than 0, okay, so not a constant, then the equation f of x equals 0, so if we set our polynomial equal to 0, has at least one root in the complex numbers. So what this is telling us is that if we're going to solve a polynomial, we can find at least one root. Now, remember that a complex number can be just a real number or it can be an imaginary number, right? So a complex number is a real part and imaginary part, but the imaginary part could be 0. So we could be looking for a real root, or we could just be looking for imaginary roots, but we're going to find at least one root. So this tells us that we can actually solve every polynomial. So that's why we actually tackle these things. So things to keep in mind when you are solving a polynomial. You're looking for as many answers as the degree of your polynomial. So if you have degree 3, then you're looking for 3 answers. You have degree 5, you're looking for 5 answers. But you might have repeated solutions. In that case, every repeated solution counts. So you might have 2 repeat 3 times. That counts as 3 solutions. And to get to these solutions, you can factor, okay, and then set to 0 using your zero product property. Or you can use your possible rational zeros, which is your p over q, and you can check those. So let's start here. We're going to solve x squared minus 14x plus 49 equals 0. State how many solutions it's going to have and what they are. Well, it really looks like it's going to have 2 solutions, and it's a quadratic, so it should be fairly simple to factor. In fact, it's a perfect square trinomial, but I'm going to go ahead and go into 2 binomials. So x and x, 7 and 7, and they're both going to be minus. So x minus 7, x minus 7. So I need to set both of these equal to 0. That's a minus 7. And I'm going to get 7 in both places. Now you don't need to list it twice, you just list it once. But we call it a double root because it happened twice. And we'll talk about this, but you find double roots where it bounces off the x-axis. So then this is actually going to be its vertexes on the x-axis. Alright, so how many solutions are there? There was 1 solution, and what is it? It was positive 7. So here we have x to the 4th plus 3x cubed minus 8x squared minus 22x minus 24, and I probably forgot the equals 0 part, equals 0. And so how many solutions, what are they? Well, it's going to look like we're looking for 4 solutions. Okay, we're looking for 4 solutions. Because it's 5 terms, we really can't factor. So we're going to use our rational zeros, our p's over q. And q is going to be 1 because we have a leading coefficient of 1. But for p, I need all of my factors of 24. So let's see here, p over q, so plus or minus 1 over 1. And 2 goes into 24, and 3 goes into 24, and 4 goes into 24, and 6, and 8, and 12, and 24. So we're going to do our synthetic substitution to check, or synthetic division. So list out your coefficients. It's an 8. Alright, and then we got to pick a number to start with here. Well, let's try 2. So if I pick 2, drop, multiply, add, multiply, add, multiply, add, multiply. Okay, that's not going to work. So 2 did not work. Would negative 2 have made any difference? Let's see here. We do negative 2, drop, multiply, add, multiply, add, multiply, add, multiply, add. Nope. Alright, so it's not 2 or negative 2. So when you erase those, I'm erasing them because I'm going to run out of room here. Really, you probably should keep them on your paper just so you can verify you did try them. Well, let's give 3 a try. So if I put in 3, I'm going to drop, multiply, add, multiply, add, multiply, add, multiply, add. Oh, good. There we go. Alright, so 3 worked. And so remember, now you can use this set of just 4 coefficients instead of all 5. And we can get rid of everything that's not a factor of 8. So we could get rid of the 24 and the 12 and the 6 and even the 3. Alright, so we're left with 1, 4, and 8. I'm going to try negative 4. So here we're going to have negative 4, so we're going to drop, multiply, add, multiply, add, multiply, there we go, add. So negative 4 is the solution. So the idea is, we started with an x to the 4th, we divided once and got an x cubed, we're now down to an x squared. Can you solve an x squared? Okay, so if you can whittle it down to an x squared, so this is x squared plus 2x plus 2, I want to solve that quadratic for my last 2. And notice that's not going to factor because you're not going to have factors of 2 that make 2. So let's complete the square. Let's move the 2 to the other side. And to complete the square, we're going to take half of 2, which is 1, and square it, which is 1, and add 1 to both sides. So then we're going to factor into x plus 1 squared equals negative 1. Square root both sides. X plus 1 equals I. We'll go with plus or minus I. And then move our 1 to the other side. So we're going to get negative 1 plus or minus I. Alright, and there's 2, so then we have a total of 4 solutions. Alright, we'll do some more examples in class, but make sure you have this written down and that you understand what we did. Let me know if you have any questions, and have an awesome day.